Okay, so Bismillahirrahmanirrahim. So hi guys, I hope you all in a good shape, right? So for this week we are continuing for our statistical method. So in the end we are going to come with this last chapter 7, the chi-square test and Anova test. So yang ni adalah topik kita dan chapter kita yang terakhir lah untuk this subject. Okay, so ada dua topik ada dua subtopic in this topic, which is cover for the chi-square test and Anova test. So for these two we are combining into one chapter 7, because the method is similar, okay, sama, dan juga method dia sikit-sikit je lah. Okay, so chi-square sikit, Anova sikit. Okay, kita tak pergi lebih deep. Right, so this two will be very usable in you punya life kemudian lah. Okay, sangat berguna. Kemudian kita akan tengok kenapa sebab. Okay, sebab kita nak belajar this one. Alright, so first let's look onto the learning objective. So by the end of this chapter, students should be able to first use contingency table to find the expected frequency. Let me draw this one. Okay, kita merah lah. Okay, so to find the expected frequency, and then the second one, use chi-square distribution to test whether two variable are independent, and like satu kita akan pakai Anova. Satu kita akan pakai, okay, untuk contingency ni, yang ni adalah the chi-square distribution untuk find dia adalah independent. Satu lagi method adalah by using the Anova to determine if there is a significant difference between 3 or more means when sample are equal or unequal. Alright, so kalau saya nak ringkaskan dalam this chapter, untuk kita punya chapter 7, kita nak ringkaskan lah. Okay, so kita akan bagi kepada dua. Okay, so first is about the chi-square independent test. Okay, chi-square independent test. Okay, so for this one is Anova test. Okay, Anova stands for analysis of variance. So maksudnya kita akan compare dia punya variance kemudian. Alright, so first satu persatu kita akan tengok. First kali is about the chi-square independent test. So the name itself is about the independent test. Nampak, independent. So maksud dia independent. Okay, so kalau you revise back into our chapter 6, kita dah learn the y and x. Okay, kita ada dua variable. First we have y variable and then x variable. So yang mana for this one kita dah panggil y adalah our dependent. Okay, dependent variable, and x is our independent variable. Okay, ini dalam chapter 6, in our chapter 6 previously. Alright, so for chapter 7, okay, we will look up whether we want to test whether x is independent with y. Okay, or in other words, y is independent with x. So we want to look how independence is x and y. Okay, how independent, is it independent or not? Sama ada dia adalah faktor ataupun tidak. Okay, so kita nak kaji untuk this one. Right, so chi-square independent test, kemudian kita akan buat. And next one, for the Anova test. Okay, Anova apa yang dia nak cari sebenarnya? Okay, so lepas kita dah dapat independent test, okay, lepas we know, let's say we know a situation where the x is an independent, y depend on x. Okay, katalah kita dah dapat nanti y is depend on x. Okay, so once we know that y depend on x, so for this one, bila kita nak buat eksperimen, okay, of course lah, so katalah y ni adalah let's say y is the hardness of steel. Okay, the hardness of steel adalah, okay, dia depends on, let's say depends on temperature. Okay, temperature. So for experimental setup nanti, so apa you akan buat, you akan test untuk the different temperature, right? Okay, for example, kita nak tengok X1, katalah saya label X1, saya letak suhu dia 70 degree Celsius, for example. Okay, so X2, okay, saya letak sini 100 degree Celsius. X3, Letak sini 150 degrees Celsius. So for these three temperature, I want to look for the hardness still. Okay, so kat sini saya nak tengok adakah bila saya ubah dia punya temperature, okay, whether I change its temperature, okay, the hardness of steel will change too. Dia akan berubah tak? Dan kalau berubah, adakah dia berubah tu secara banyak ataupun tak ada beza pun? Okay, will there be any difference or the result will similar? Kita nak tengok antara ketiga-tiga suhu ni, kita panggil dia significant. Okay, result yang mana paling significant? Misal kata X1 and X2 give the same value for the hardness. So bila kita buat test X1 X2, dia tak bagi banyak perubahan pada hardness. But when we take X3 150 degrees Celsius, yes, it given the significant for the hardness. Okay, so baru kita boleh kata yes, dia bawa perubahan kepada hardness of that. So this one is very important. Okay, so dua-dua ni actually important. You want to know the impedance, and next one you draw the conclusion based on the Anova test. Okay, this one secara dasarnya kita akan masuk lebih dalam lah. Okay, alright. So so we start now. So chapter 7 introduction. In this section we'll cover about the contingency table, finding expected observed frequency in order to test two variable for independent using chi-square independent test. Okay, so first one kita start dulu 7.1, test two variable for independence. Ni macam kita cakap tadi lah, kita nak test for independence. Okay, so for test for independent, we must have the contingency table. So untuk contingency table ni, since kita pun belajar online, we are doing online PMP, so I think tak ada masalah you nak buat untuk contingency table. So pakai Excel ataupun you nak tulis pun boleh, tak ada masalah. So in general there are categories for row variable and C category for column. Okay, so ini dia bagilah. First we have row variable, row, and then this one a column variable. Okay, alright. So dalam bahagian ni kita bahagikan kepada O and E. O is the observed frequency. So O is given, E is the expected frequency. E dia kita kena cari. Okay. Okay, so let's say you have this kind of table. So O11, O12, O11, meaning that O row 1 and column 1, O12, O row 1, column 2, O21, O row 2, column yang pertama, O22, O row 2, column yang kedua. Okay, so first of all, when you have this kind of table, okay, this one akan be dalam bentuk data lah. Okay, so cari dulu dia punya summation N1. This one summation N2, this one summation N1, summation N2. Okay, and then yang paling penting cari dia punya total dekat sini. So sama macam yang kita buat dalam chapter sebelum ni. Okay, okay, so the general formula to obtain the expected frequency. Now, okay, untuk kita cari the expected frequency, kita akan pakai this formula. Okay, Ni times with NJ meaning that this one is row, this one is a column over by total, baru kita dapat expected frequency. Okay, so first of all, okay, let's look for this one, the chi-square independent test. The chi-square independent test is used, this one kita akan masuk independent lah, whether or not the occurrence of one variable affect the other. Nampak whether the occurrence of one another affect the other. So which means dekat sini kita nak tengok Y dengan X, whether Y will affect by X or not. Kita nak tengok. Okay, the test statistic for the chi-square independent test is given by this formula. This one memang nama dia chi-square, so you tak perlu nak square root. Dia memang nama dia chi-square. Sini, okay? Memang nama chi-square. So given by this formula, OIJ minus with EIJ square over by EIJ. This one kita akan tengok one by one lah. How to do this one. It is approximated by a chi-square distribution, R minus 1 minus 1 degree of freedom, where O represent the observed frequency and E represent the expected frequency. Okay. Okay, so first of all, bila kita nak buat test, okay, apa-apa pun mesti ada hypothesis punya statement. Dia lain sikit daripada chapter yang 5 sebab this one untuk chapter yang ke-6, for chapter 7 you just follow dia punya hypothesis statement. Okay, so first H0, the row and column are independent, not related, which it ada. This one dia punya hypothesis statement independent. The row for alternative dependent. X has a relation with Y, X has no relation with Y. Okay, H0, X and Y independent. Okay, independent maksud dia bebas antara satu sama lain. Maksud dia tak related lah. Okay, independent. Okay, not related. Okay, then H1, X and Y are dependent. Okay, nampak beza independent tak related satu sama lain. So X has no relationship with Y. So untuk dia punya alternatif punya statement, X and Y adalah dependent. Okay, so sama dia nak pakai ayat ni ataupun not related pun boleh, ataupun dia nak pakai ayat yang bawah ni pun boleh. So ada 3 ayat yang boleh pakai. Okay, tak perlu pakai ketiga-tiga. Okay, so this one is the procedure. So first state the hypothesis, second one compute the chi-square independent test. So this one you kena buat table sikit, and the third one find the critical value. So this one dapat daripada table of chi-square distribution, make decision. Okay, yang ni decision kita, yang ni penting lah. Okay, so reject H0 if chi-square test is greater than 2 je. Okay, kita reject kita punya H0, then make a conclusion. Okay, sama ada this one independent ataupun tak. Okay, so let's look onto one example. Chapter 7 ni senang je, don't worry too much lah. Okay, sebenarnya. Okay, so example 1, the manufacturing company wants to study the relationship of the presence of the sodium carbonate towards the compression strength of sodium composition. Okay, so the experimental data of the sample model are shown in the following table. Okay, so kita ada strong kita ada dua lah. Satu, we have the presence of sodium carbonate, okay, toward the compression strength. Okay, ada punya strength. So kat sini kita tahu X is the sodium carbonate. Okay, Y is the compression strength. Kita nak tengok dia punya hubungan ni, sama ada sama ada Y dipengaruhi oleh X or not. Okay, independent or not. Okay, so you have this scan table. Okay, so at alpha 0.01, can the company conclude the present is not related with the compression strength of molding and sand composition? Okay, so first dia punya solution, okay, always have dia punya H0 and H1. Okay, sodium carbonate present is not related. Nampak dia punya H0 dia X is not related with compression Y. This one is Y. Okay, and then dia punya H1 is as follows. Alright. Okay, so sebab dia claim dia letak sini sebab at alpha 0.01, can the company conclude that the present is not related of molding? So conclude the present, the company conclude is not related. So maksud dia claim dia not related lah, claim yang atas. Okay, and then dia pun daripada table. So ini daripada table tadi. Okay, 20, 40, 10, 80. So for this one, kalau you tengok balik, so this one is O11, O12, O21, O22. Ini kita kata sebagai observe variable. So bila observe, find dia punya total. 20 plus 40, you dapat sini 60. 10 plus 80 dapat sini 90. 20 plus 10, 30, 40 plus 80, 130. Find dia punya total kat sini. Okay, so untuk table ni digabung sekali dengan bahagian O dengan E. So sepatutnya dia ada space lah kat sini. Okay, kena ada space kat sini. Alright, so now baru kita akan cari dia punya expected value. Okay, so dia pun buat table yang kedua. Ini dia buat sini table, this one. Okay, buat table sini. So O sini bahagian E, so di sini OII minus EIJ over by EIJ. So di atas kita ada square. Okay, untuk yang pertama O11. Okay, O11. So dekat bahagian 20. So how dia nak cari E11? Okay, nampak sini O11. Saya ambil pen lain lah bagi nampak. Pen ni purple. Okay, untuk bahagian yang pertama, dia ambil yang total semua sekali. Dia ambil yang total bawah. Okay, baik. So, untuk kita cari E expected, okay, dia ambil nilai ni. 60 multiply with 30 over 150. Okay, again, this one. Okay, there. Again, 60 multiply with 30 over by 150. So, dapat sini 12. So then use formula OII. So 20 minus with 12 square over 12. So dapatlah sini yang pertama 5.333. Okay, so kita beralih kepada yang kedua. Tukar pen. Katalah this one. Okay, yang kedua O12. Okay, observe. So yang kedua. So again dia ambil total semua sekali darab dengan yang bawah. 60 multiplied with 120 over by 150 by. Okay, so dapat sini 48. So then use formula 40 minus 48 square over 48. So dapatlah sini. So konsep dia akan berulang. Sama juga untuk yang ketiga. Okay, saya contoh lah. Kalau apa pula hijau lah. Okay, untuk bahagian sini pula. Sini, ambil sebelah sana dia punya kolom, row, ambil dia punya kolom. So 90 multiply with 30 over by 150. Dapat sini 180. So then 10 minus 80 square over by 80 3.5556. Okay, and then teruskan yang terakhir. Okay, and then nilai ni semua you akan tambahkan saja. So you akan dapat nilai chi-square independent test. Gitu je, tambah semua sekali bawah. So you dapat 11.1111. Okay, so this value tak perlu nak square root. Sebab ada student dia suka square root kan, pantang nampak. Okay, so chi-square test is 11.1111. So it is our chi-square test. Ingat, next one, step yang ketiga, kita nak cari untuk kita punya critical test. Tukar pen, sorry. Okay, critical test. Okay, so chi-square critical equals to chi-square. Nama dia memang chi-square, jangan berubah. Alpha R minus 1 C minus 1. Okay, R minus 1 meaning that kita punya row yang asal. Okay, the original row we have 2. The column row pun kita ada 2. So that's why R minus 1 C minus 1 2 minus 1 2 minus 1. This one you kena multiply. 2 minus 1, for this one I have 1. Okay, multiply with 2 minus 1 pun 1. So meaning dari kat sini kita ada chi-square 0.01 and then we have 1. Okay, so nilai ni macam mana nak cari daripada table? Okay, saya pun kena buka table lah. Okay, sekejap ya. Okay, so binomial. So teruskan kepada chi-square independent punya table. Chi-square. Okay, chi-square distribution punya table. Satu je saya rasa. Okay, chi-square distribution. Alright, so how to find from the table? So saya akan letak, I think boleh tak saya letak sebelah-sebelah. Saya buka balik yang tadi. Cuma saya nak sikit. Sorry Okay, saya terpaksa keluarkan and saya continue lah. Alright, so saya nak letak dia sebelah-sebelah supaya nampak. Okay. Alright. So chi square 0.01 and then this one is 1. Okay, first kali kita cari dulu untuk 0.01. Okay, dalam table alpha 0.01 situated here. Okay, situated right here. Okay, so 0.01 and then kita punya degree of freedom. So this one dipanggil sebagai degree of freedom is 1, so 6.635. Nilai yang sama. Okay, 6.635 daripada table. Okay, and then step kita yang keempat, kita comparekan, make decision. Ingat kita punya comparison chi square, kalau dia lebih besar daripada chi square alpha, okay, degree of freedom, kita akan reject our H0. Okay, ini kita punya decision. Okay, so chi square 11.1111 greater than this one, so then we reject our H0. Okay, so since we reject our H0, conclusion, kita tengok balik yang atas. Okay, kita reject kita punya H0. So this one kita nak reject kan. Okay, so claim dekat atas. So which mean since we reject H0, then there is insufficient evidence to conclude that the presence of sodium carbonate is not related with the composition. So maksud dia ada relation, dia related. Okay. Okay, so let's look onto one exercise yang bawah. So a group of excellent students were asked to make decision whether they will choose the lecturer who have the research grant or not to complete their final year project. So the students were grouped into different field and gender. A researcher was interested to study the relationship between the student choice and the different field. Okay, so ada dua field dengan different choice. Result is obtained as follows. Okay, so ada design, hatchback, student choice. So untuk dalam table ni dia dah bagi dah kawasan count, okay, kawasan observe, kawasan expected. Okay, so total pun dia bagi 130, 20, 10, 160. Okay, alright. So ini dia buat lah. Okay, so first of all, H0 and H1. Okay, H0. So the choice is independent to their field of study. So independent, atas ni, bawah sini adalah dependent. So Y and X are independent, Y and X adalah dependent. Okay. Right. Okay. So first dia dah bagi dia punya total, and then apa yang kena buat lah? Total dah cari, so we cari expected lah. Okay, sama dia nak penuhkan this table pun boleh. So untuk cari expected for this one, 130, 60, this one 259. Okay, ingat balik how to find dia punya expected. Okay, 160 multiply with 259 over by 320. So you akan dapat balik expected. Okay, kalau nak senang buat dalam bentuk table macam ni, sebab you boleh tambah bahagian yang belakang OIJ minus EIJ square over by EIJ. So this one you akan dapat 129.5. So minus this one you akan dapat square over this one 0.019. Okay, teruskan sampai habis, then you akan dapat chi square is equals to 5.9501. Okay, chi square test 5.9501 chi square test. Right. So next one, chi square critical. Step ketiga. Chi square critical, chi square alpha 0.05, R minus 1, C minus 1. So R minus 1, kembali balik pada original soalan. Okay, R minus 1. So dia punya row ada dua, design and hatchback. Okay, row ada dua. So R equals to 2. Okay, and then dia punya column, yes, no, uncertain. So which means C column dia ada 3. Okay, so 2 minus 1, 3 minus 1. So that's why dia tulis sini row minus 1, 2 minus 1, column minus 1, 3 minus 1. So 2 times 1, so sini you akan dapat 1. Okay, multiply with 3 minus 1, you akan dapat 2. So you akan dapat chi square 0.05, this one is 2. Okay, now kita akan check daripada table. Okay, so 0.05, now dekat bahagian sini pula, and then 2 chi square independent, and degree of freedom 5.991. So 5.99. Okay, so next one. Okay, so since kita punya decision kita, since chi square kita is greater than this, sorry, is less than this one. Okay, so we fail to reject the conditional. As we conclude, the student is not related or related to the field of study. Okay, so that, I think that's okay. Kita to exercise, kita boleh tengok lah for this one. So sama je step dia, kita tengok the independence. Okay, so next one, saya beralih kepada Anova.